our next step pattern is a little bit more challenging. So what I do on these is I try to look for a 1 by 1 square and then other pieces. So I notice I have a 1 by 1 square and then plus 2 other squares. So we have 1 squared and then plus 2. And then here I notice I have a 2 by 2 squared. So 2 by 2 squared. But then if you notice here, I don't have my two repeating patterns of 1. So I can write this 2 as 2 of these times 1. But if you notice here, I have my 2 of these times 2. So I can write 2 and then times 2. Then if you notice for step 3, I have my 3 by 3 squared. So 3 squared. Plus I have 3 of these repeated twice. So I can write that as 3 times 2. So the next step, I'm going to have a 4 by 4 square. And then I'm going to have 4 of these. So I'm going to have another 4 on top. So again, I have my 4 by 4 square. And then I have my 4 pieces of 4. So we have 4 squared plus 4 times. Oh, and I put 4 times 4. It's actually 4 times 2. So my fault. I need to get rid of those parts. So again, if we're looking at this pattern, we need to see, is this growing linearly? So what we can do is just make a table to look at that. So we have the step 1, and then we can put squares. So step 1, we had 3. Step 2, the total squares, we have 1, 2, 3, 4, 5, 6, 7, 8. Step 3, we have 9 plus another 6, which is 15. So if we're looking at that increase to go from 3 to 8, 8 minus 3 is 5. And then 15 minus 8 is 7. And for our fourth here, we have here would be 16 plus another 4 and 4. So that would be 24. And if you look, that's increasing by 9. So if I'm looking here, this is not linear because I'm not adding 5 each time. So now to represent the pattern, Diego and Jada wrote different equations. So Diego wrote, you have n times n plus 2. And Jada wrote f of n. So I can put my f of n too to write that in function notation. So Jada wrote f of n equals n squared plus 2n. And we can see, can we relate these? Well, I can take Diego's expression and expand that. So I can go n times n, and n times n gives me n squared. And then n times 2 would be plus 2n. So we just showed mathematically these two expressions are the same. So the expressions on the right side are the same, which means the equations are the same.